This video is for someone who's new to the team, or if you're just curious about the concepts that we use as we build the Qvanti and Flavy platform. So without further ado, let's jump into the concepts that we need to go through. So the first concept that I want to emphasize is domain-driven design. So way back when we were starting out as just a website selling beer, we started by using domain-driven design. The idea is that we want to capture the words and the processes of the people that we're trying to support with software. This helps us understand the business better and build software that more aligns with business values and business goals. And it also helps our users to use the software because it's written in the language with the words that they themselves use. So working with domain-driven design, focusing primarily on the entities, the words that people use, but also the business events, allows us to create software that closely aligns with the business and also delivers a high degree of business value earlier, because the business value is shown and it's appreciated by developers just as well as the people working in this. Using domain-driven design, we can see that we can become more flexible because a word, a meaning in the business doesn't necessarily change as fast as the technology. So we can sort of change technologies or the way we solve the business need, but we already know what the business need is. That makes it easier for us as developers to reduce complexity and create software in a more flexible way. Using the business language or the language of the users will allow your software to keep being aligned with business and user needs for longer, because the technical jargon will always get in there. The next concept that we should focus on is event sourcing. After we briefly talked about domain-driven design, we heard the word event. So business value is usually, or at least in software, focused around events. You have a new customer, this is an event. You have an order that's placed, this is an event. You have a new subscriber, this is an event. All of these carry value. So keeping track of the business events and designing the software around the business events means that we can measure them, we can keep track of them, and we can keep them close to our hearts. A piece of software a system that's been doing this for centuries, if not more, is in fact accounting. So way back in Venice, in the Middle Ages, if not earlier, in Babylon and whatnot, keeping track of the business events of cash flow coming in, corn being shipped out, is done through accounting. It's more or less been the same for thousands of years. Event sourcing is the same. We keep track of all the events going through our system so that we can always go back and look, oh, is this correct? What happened? Why is this number that? We can follow our source of events, our events source if you want, back in history and see why that happened. Coming from event sourcing, I briefly mentioned services. And we have a multitude of services in the Qvanti platform, if you will. What we're doing is we're dividing up the domain so that we can distribute load across the different domains, but also give them different responsibilities. So, for example, the login service or the services handling login, they're not related to the services handling the order management system. Why? Because the order management system is specialized on handling orders and login is not specialized on handling orders. We can have two different people working on these systems at the same time and they won't interact with each other. So we're trying to encapsulate part of the domain in a service. So orders going one service, we have a service for handling the shopping carts and the shops. They're different from the actual order fulfillment, and therefore they're in two different domains. By doing this, we can keep a service that has its own persistence. So we already, based on the domains that we split out, we can already then start splitting out the persistence of these domains, making it easier for us to balance the load of the system or increase the capacity in parts of the system that requires more capacity without affecting other systems. we can also upgrade a part of the system without the other parts really needing to know about it. We can have that means it's easier for us to have a zero downtime deployment setup because we have different services that can be upgraded in different sequences. All of these services, they work with the domain-driven design with events, but I can't mention events without also mentioning actions. So there's a difference between an event and an action. You can take an action, place an order, but that does not guarantee you that that order is placed. For example, if you, for some reason, have not filled in invoice details or delivery details on an order, you cannot place that order because that would be like we can't deliver on that. The order fulfillment part can't succeed with that. So you can place the request, you can do the action of placing that order, but an event will not be registered for that action because for some reason you can't really place that order right now. Once you fix that, you can do the action again, and the event will be raised, and the business logic applied to that will actually be executed. So this is the difference between the actions and the events. So what we're doing is, when we're describing our domain model, we're also describing the actions that the users can take. So an action is sort of like, I have the intent of placing this order, but the system might not allow me for various reasons. So the business logic is then implemented in the action to make sure that, all right, cool, Morten wants to place this order. Can he do that? Let's look at the order. Okay, it has the invoicing address, it has the delivery address, we have everything in stock. We can all do all these calculations, and if everything checks out, then yes, cool, the order is placed and we can carry on. So as we try to capture these user intents, we try to describe them as actions that the user can take. So you can place an order, you can invoice an order, you can ship an order. The events would naturally then be order placed, or order shipped, or order invoiced. Maybe even invoice created at one point, right? But there's a difference of the actions that you take and the events that are raised because of the actions. So the actions are sort of meant to guard any misuse of events, keeping the amount of events that we have as low as possible. Especially since we're doing all the replays, remember? And that means we sort of want to have as few events in our event source as humanly possible. Talking about actions and talking about events will naturally lead to having a discussion about idempotency. Now, this is more of a concept that you sort of need to know, because this is something that I try to stress a lot. Replays will happen. Actions will be called over and over again. It can be a user that double clicks, it can be a malfunctioning router, it can be a user who has a bad Wi-Fi connection or a bad connection on their cellular network that will cause extra actions to be executed. It can also be your high availability system just sending you an extra message to make sure you got it, because hey, we're a highly available system, so that might happen. And making sure that we handle these replays is really, really important. And therefore we try to write our actions in a way that they are idempotent. This means that if I do the action place order and the event order placed has been raised, if I do place order again, nothing will happen, because the order is already placed. The intent that me as a user that I have done has already happened. We're good. We're fine. Everything's going to be good. However, if I had, for example, a add order row action, then adding an order row will create an event that adds one more row to the order. Now, this action would then not be idempotent, because if there's a replay, all of a sudden you have 2 rows or maybe 3. And this is exactly something that you want to avoid in a system that handles money. So making sure that our actions can be replayed twice without causing any extra events is really, really important, and something that we put a lot of effort into. And the word for replaying these functions and having nothing really happen is called idempotency. And it's a really important trait to have in a distributed system or a high availability system, or any system that sort of interacts with a network. but that's a different story. Actions are raised from the user interface, but they're called to the intention that the user has sent to the server on the backend. And we do this through an HTTP API. It's inspired by REST, but it is not REST. This is in fact the CQRS pattern. So all of our sort of entities can be accessed in this REST-like fashion, but every mutation that you do needs to go through the action endpoint. So we're separating out the command and the response, so to speak. So writing is not the same. It's not the same model as reading. Apart from that, the reading model is highly inspired by the REST protocols, where you sort of have a directory-like structure. And it makes it easy for people to sort of know where to go and look for the data from the front end, because, well, they all follow the same naming conventions, they all follow the same paths, right? So you know where to look and you know how to access data. Now, our list endpoints are very, very powerful, but we'll get more into that in a later video. As we have our REST APIs, I have to mention something called gateways. The gateways are sort of where the REST APIs are implemented, but our microservice architecture on the backend does not talk HTTP. It is in fact a message passing system. The reason for this is it allows us to have a highly available system with multiple processors just helping out delivering like the user's needs. And that allows us as well to have uptime while we're upgrading the system over time. However, passing from HTTP into the messaging system goes through one of our gateways. The gateways will check if you're a valid user, if you're logged in, if you have access to like what you need to, and then it will send your message further into the system to the correct service that should handle the action or like the query that you're trying to execute. So the gateway will validate all requests coming through it and make sure that you're allowed to access that kind of system. It does this by checking your credentials as you come in and then assigning each request a session user variable. So you can see the session user variable sort of like a passport or a visa, if you will, that allows you to access data throughout the system, or like every service will check your session user and see, oh, okay, yeah, you're allowed to read this order. I can give you this information. You can do nothing in our system without going through either the gateways or having one of these session user tokens. So that's sort of where we keep our security in check. So be sure to, or be mindful as you work through it with our system of like, oh, cool, yeah, this is the session user. I know who this is. I can check things on the user, right? All right, so the last concept that you sort of need to know about is the Monorepo concept. And we keep everything in one repository. All these services, all the gateways, all the front ends, all the clients in our platform, they're stored in one repository. And this allows us to make sure that we test all these parts of the system to see if they work together still. We know that every time we do a release, we can see that the parts of the system will still work together and interact with each other the way we expect them to do. We also know that we follow the same coding conventions. We know that we can keep track of all the dependencies in our system and make sure that we don't have a multitude of versions of the same dependency, reducing, in fact, our package size, but also, the risk for security issues. It also describes a physical layout quite clearly of, oh, okay, so I want to look at the microservice for the orders management system, then I know that that can be found under the services folder and then under the order management system, right? So you can clearly find, it makes it really easy to find where things are in our code base and where you should put them. Hopefully, by knowing where things go and where to look for them, this makes it so much easier for us as a team to work together to deliver the software. That's all the concepts, no, not all the concepts. That's some of the concepts that you would need to know if you're starting in our team, or if you're just curious about how we work, or if you want to listen to some of my upcoming videos. I might drop or talk about all these different concepts, and well, here's the starter. Hopefully I can go into more depth on almost all of these concepts, and I hope to do that as I get more time. If you like this, there's a like button that you can press. You can also subscribe to get more of this content, and you can subscribe to my newsletter because yeah, that helps. Yeah, cool. All right, see you later.